This video is sponsored by Maxon Motor. Hi, I'm Miles Budimir with Design World Magazine, and we're here to continue our ongoing motion control basics series, and we're here to talk about brushless DC motors today. A brushless DC motor is basically a DC motor without the mechanical commutation of the brushed DC motor. Brushless DC motors are powered by direct current and have electronic commutation systems, instead of the mechanical brushes and commutators used in brushed DC motors. All DC motors generate a magnetic field, either via electromagnetic windings or permanent magnets. An armature, which is often a coil of wires, is placed between the north and south poles of a magnet. When current flows through the armature, the field produced by the armature interacts with the magnetic field from the magnets and eventually generates a torque and thereby motion. For motion control applications, the most common DC motor types are the basic brushed DC motor, brushless motors, and permanent magnet motors. Now, in a brushed DC motor, the magnet acts as the stator. The armature is integrated onto the rotor, and a commutator switches the current flow. The commutator's function is to transfer current from a fixed point to the rotating shaft. Brushed DC motors generate torque straight from the DC power supplied to the motor by using internal commutation, fixed permanent magnets, and rotating electromagnets. Brushed DC motors have the advantage of generally low initial cost and simple control of the motor speed. However, there are some drawbacks. At certain periods during the DC motor rotation, the commutator must reverse the current, causing reduced motor life due to arcing and friction. Consequently, brushed DC motors require more maintenance, such as frequently replacing the springs and brushes which carry the current, as well as replacing or cleaning the commutator. Now, brushless DC motors, on the other hand, do away with the mechanical commutation in favor of electronic commutation, which eliminates the mechanical wear and tear involved with brushed DC motors. In brushless DC motors, the permanent magnet is housed in the rotor, and the coils are placed in the stator. The coil windings produce a rotating magnetic field because they're separated from each other electrically, which enables them to be turned on and off. The brushless DC motor's commutator does not bring the current to the rotor. Instead, the rotor's permanent magnet field trails the rotating stator field, producing the rotor field. For successful commutation, it's important to have precise rotor position data, which is often achieved via magnetic sensing with the Hall effect sensor, which also allows for tracking of speed and torque. Brushless DC motors have quite a few advantages over their brushed counterparts. Compared to brushed DC motors, brushless DC motors are more efficient due mainly to the elimination of the friction from the brushes. They're also more reliable and typically have longer lifespans. Getting rid of the brushes also means a decrease in EMI, or electromagnetic interference, noise, and no sparking from the brushes making contact with the commutator. Some servo motor systems use brushless DC motors instead of other types of motors, either a brushed DC motor or an AC motor such as an induction motor. Brushless DC motors are used in everything from low-power applications such as consumer products to high-power applications in electric vehicles and industrial equipment.